Good morning students. In this video we can discuss about symbol table. So in this video we should cover these are the several sub concepts like introduction to the symbol table. So in this session we can discuss what are the major role of the symbol table and why we are using the symbol table in compilers. And next what are the several entries for the symbol table. And next what are the several operations can perform on symbol table and symbol table organization. So we should discuss these four concepts in this video and remaining things can be covered in next video. So coming to the first one, so introduction to the symbol table. So already we discussed from the beginning of the compiler design. So at the time of performing the compilation or compiler, so we are using the symbol table entry. So that means actually this entire compilation process is divided into several phases. Out of those, first phase is the lexical analyzer. So actually this symbol table was created or started at lexical analyzer, and then phase by phase their usage or their utilities can be provided or utilized by the several phases of the compiler until end of the phase. So here this symbol table can be treated as some data structure, and this data structure can maintain several information, that means either maintain or stores the some information about the name and type and scope of the variables to perform the several tasks or several operations perform defined by the phases of the compiler. So that means based on the phases of a compiler, that means based on different phases which can perform the different types of functionalities and operations. So out of this which can maintain and store the some information about what is the name of that particular identifier or variable, which type of, what is the type of that one, and what is the scope of that particular variables, and this type of information can be maintained by the symbol table. So now we observe what is the role of the symbol table in compilation process in each and every phase. So for example, consider the first phase, lexical analyzer. So in this phase we are creating the symbol table. So for each and every entry for entry for the each and every identifier. So that means at the time of creating the tokens, so at that particular time, so it creates, that means lexical analyzer can create entry to the symbol table for each and every identifier. And next, syntax analysis. So in this phase symbol table can add the some additional information to the already existed data, whatever the data was existed from the lexical analyzer. So such information is available in syntax analyzer. Addition to that information, it can add some information like as what is the type of that particular variable, and what is the scope of that particular variable, and whatever the dimensions of that particular variable, and whatever the line of references and line of use. So that means that particular variable can be used by in which lines of the code. So such type of information. And next, in semantic analysis, so semantic analysis also use the symbol table information. So whatever the information available on the symbol table, based on this information it can perform the checking of semantics. So for that purpose semantic analysis also using the symbol table. At the same way, intermediate code generation. So this phase is also uses the symbol table. So it was used to create the temporary variable information. So it can create some temporary variable information, and such temporary variable information can be stored into symbol table. So for that purpose intermediate code generation can be used the symbol table to store such information. And next, optimization. So while we will go for developing the target code, so before developing the target code, to optimizing the machine dependent target code or machine dependent optimization. For that purpose, so we can use symbol table information. Based on this information we will try to optimize the whatever the useful symbols and whatever the useless symbols, such things can be modified, and then whatever the useless symbols, such useless entries or useless symbols can be removed from the symbol table entries. For that purpose we are using the symbol table in code optimization. And final thing is the code generation. So in this phase we are using the symbol table information to generate the target code by using whatever the addresses of the several variable or whatever the information we are used to generate the target code. Such information addresses can be used by the code generator to generate the target code. So these are the different phases uses the symbol table in compilation process. So now we observe or we discuss what are the several symbol table entries. What are the different types of entries can be used in symbol tables. So here each entry in the symbol table is associated with some attribute to that support some attributes. So such attributes are supported by the compilers. So that compilers can be based on the machine dependent. So that means based on the machine or based on the languages. So whatever the compilers was generated based on those compilers. So here several attributes can be supported by the symbol table. So like here attributes means like as either name of the variable, size of the that particular variable, dimension. So that means either in array type of variables we can use this such dimension, either type of the variable, and line of declaration and line of use. So such type of information, these type of attributes can be used. This type of attributes can be used in symbol table entries. So here there is a small differences or there is some distinction between token ID and identifier. Token ID for identifier and name. So here in case we are using some lexeme, so that lexeme is used mainly to distinguish the attributes of the one variable from other variable. So for that purpose we are using the lexemes. So whenever we are performing the lexical analysis, so in this process such lexemes can be correspond to the an identifier is found. So that means that particular lexemes can be identifies which type of identifiers, and it first of all so in case that lexical analyzer can identify the some lexeme or some identifier, then first of all it will check that particular identifier is already existed or already created on the symbol table or not. In case which is already available, then we can use the line reference or line of declaration. So we can reuse the that particular existing identifier or existing attribute. So that particular attribute can be available in that particular attribute or that particular that particular identifier or that particular token can be available on which line. So simply we can reuse that particular line reference. And then in case that particular identifier is already not available in the symbol table, then we can create the new entry for that particular identifier in the symbol table. So this is the procedure for while we will go for creating the symbol table in lexical analyzer and the related attributes. So for example we consider some example like as there is some attributes either name, age, address and phone number. So then here whatever the several types attribute types or several attribute entries can be added into the symbol table is what is the type of that particular attribute or that particular variable name or token name, and what is the size of that particular token, whatever the dimensions of that particular tokens, and line of declarations and line of usage and their address. So this type of information can be maintained in the symbol table. So in basic languages like as basic and Fortran, so here the variable name is fixed size, so which was very little sizes, that means which was limited to the either 5 characters or 2 to 6 characters. So in such languages we can easily create the symbol table entries, or which was better to easily create the symbol table entries. So this limit is if the limit on the length is not fixed, in case that particular limit is not fixed, then we are not able to clearly maintain the symbol table entries for each and every variables or each and every entry for the symbol table. So in case for example now we observe there is some table, so that particular table can shows the whatever the several entries for the symbol table for some for the above example. So for example we can use some high level languages like C, CPP, Java. So such type of languages can use the variable size of the identifiers. In this situation, it was very difficult to utilize or maintain the symbol table information. So now we observe some example. So in the above, already we observe the above, already we consider some example, like what are the several variable names, like name, age, address and phone number. So in same example, we can identify whatever the array reference or whatever the array reference or array memory can be used to store the such information in the symbol table entry. So for example, this is the several token names or several identifiers was used in that particular program. So such information can be, these information can be used in the symbol table. Now we observe how these all information can be stored in the array. So here it can store the first name and then age and then address and then phone number. So here we can observe each and every attribute or each and every token name can be separated with some hash or some special symbol hash. So it indicates, so end of the first attribute or end of the first token and beginning of the next token. So in between we are using the special symbol hash. So now we observe whatever the several operations can be performed on the symbol table. So while we are going to utilize or using the symbol table, we can also perform several or some operations on that particular symbol table. So especially these operations can be performed based on the type of symbol tables. That means that particular symbol table can be used for which type of languages. So there are basically two types of language. Those are block structured languages and non-block structured languages. So in case we are using non-block structured languages, so then there is only single instance of the variable declaration and a scope. So that means there was no need of multiple declarations and multiple scope of the different scope of that particular variable. So that means once we can create that particular variable, so that particular variable can be used in only one block only or only one time. So it should never varying from one instruction to another instruction or one line of the code to another line of the code. So such type of structured information, such type of structured language is known as the non-block structured languages. So in case we are using the structured languages, then the variables may be varying or declaring and again redeclaring several times. That means declaration in case we are declaring that particular variable, so in another block we can redeclaring that particular variable for another value. So in this manner, so that means that particular variable value can be varied from one block to the another block. So that is the major variation between block structured languages to the non-block structured languages. So in this non-block structured languages, so to handle the variable information, we are using some more operations. So those operations are insert, lookup, set and reset. So these are the four operations was used in the block structured languages. So in case we are using the symbol table entry for non-block structured languages, then we can use the only one operation, that is insert operation only. In case we are using the block structured languages, then we can use several operations like insert, lookup, set and reset. So here insert means we can put or we can create some variable with some token ID. So for example, insert of s comma t. So that means here we are inserting the variable s into the symbol table and the token ID is t. So in this manner, so it can be creates the one entry in symbol table. And next, lookup of s. So that means to find the already existing string or already existing identifier or variable. For that purpose we are using this particular operation. In case that particular attribute or that particular variable can be identified, then it returns that particular attribute or that particular value. In case not identified, then it can return 0. So and next, set operation. So this set operation is performed on every block. So each and every block. So entry to mark the beginning of a new scope of the variable declaration. So that means this particular set operations can be used. So whenever we are using some single variable for multiple declarations or reusages, at that situations we can use the set operations. That means within that block we can set some specific value and then use that particular value in entire block. After end of that particular block, their value can be reset to the default value in this manner. and then finally reset operation. This reset operation is used by each and every block. So this reset operation is used while we are ending from the block. At that time we can release the remove that particular value and reset to the default value or any specific value. For that purpose we are using the reset operation. So these are the several operations can be performed on the symbol table. So in case that symbol table can be used for block structure languages, then we can use these four operations: insert, lookup, set, reset. In case we are using the symbol table for non-block structure languages, then we can use only one operation like insert. So now we discuss symbol table organization. So already we was discuss some little bit about the symbol table organization. So that is, while we will go for maintaining symbol table information, we can use the any type of data structure or any data structure for the symbol table. So the performance of any compiler can be depending on the organization of the symbol table. So that means that particular symbol table organization is good, then the compiler optimization or then the compiler performance is good. In case the organization of that particular symbol table is not good, obviously their performance is also not good. So here some programming languages are supporting the implicit declarations and some programming languages are supporting the explicit declarations. So here whether some programming language supports the implicit declaration, then that languages in that languages variables can be declared or can be directly used without declaration. So that means in case we are using the symbol table operations, the symbol table organization for implicit languages, then without declaring that particular variable, we can directly use that particular variable for performing the operations. For example, Fortran, Python, so such type of languages, without declaring the variables, we can directly utilize the variables. So not exactly Python, but in Fortran we can use that particular variable without any declaration. So in these languages, to identify that particular variable is belongs to the which type, for that purpose we are using that particular variable can be declared with starting as I, J, K, L, M and N. Then we can decide as that particular variable is belongs to the integer type. Other than these 4 or 5 letters, then that particular variable is belongs to the real type. In this manner we can easily create the variables in implicit languages or implicit programming. So in this process, all insert operations can be performed first, followed by the lookup operations in case of the explicit language. That means in case we are using the explicit languages, at that situation, first of all we can declare the all variables and then we can utilize the such variables for performing the several operations. For example, now we consider different types of operations. In case we are using the linear list, then we can use arrays, linked list and hierarchical structures. So in arrays again we can use ordered elements and unordered elements. So in linked list also we can use ordered and unordered. In hierarchical we can use either binary search tree or height balanced trees. So that means balanced trees in this manner. And finally we can also use hash table. So these are the several symbol table organizations. So these are the some few details about the symbol table organization. In next session we discuss remaining concepts. Thank you.